Hi everyone, welcome to this workshop about deploying machine learning models with Kubernetes. This workshop is a part of the Machine Learning Zoomcamp course. So this is a course about machine learning engineering. And here in this workshop, I am going to update the content for this. So we already have a model. So this is the page for the course. Many of you are following the course. The course actually started in September. If you're interested in learning more about the course, there is actually a link in the description. It's still not late to sign up if you are not following the course and want to start. We are finishing module number 2, but you can still enroll. So this is the link to the course. You just click on that link and you end up on this website that I'm showing right here. Right. So right now I think we're in the regression module and we're starting with classification. But what we also do is we have a module about Kubernetes, and right now I want to first update the model because the model was recorded like 5 years ago or something like that. So it's been a while, 4 years ago. But yeah, anyways, it was quite a long time ago. So I wanted to update it slightly, although I will not focus here on the theory. So if you're interested in the theory has not changed since 2021. I think this is when I recorded it. So the theory didn't change. The practical part also didn't change significantly. But I started updating this course. So we already updated the deployment module. We updated the serverless module. We are going to update the deep learning module. So in deployment, instead of Flask, we are going to use FastAPI. Instead of using TensorFlow Lite, we are going to use ONNX, or we already have recorded workshops with that. And for deep learning, instead of using TensorFlow and Keras, we are going to use PyTorch. So that's why I thought it makes sense to also update Kubernetes and also make it a little bit less complicated. So right now, the setup we have here is a little bit complicated. So it's a TensorFlow serving model, then a Flask application in front of it. So I'm going to make it a little simpler in this workshop today. Still, if you are interested in some theory, please watch the old videos. Here I cover many things like, yeah. So what we will not talk about today, we will not talk about Docker Compose. So this is something you can still check the old module. We will not talk about EKS, which is Kubernetes that is running in AWS. We will do things only locally in this workshop. So for this, you can also check. It shouldn't have changed significantly. But the rest, so we will not talk about TensorFlow serving. We will instead use ONNX like we did in the serverless module. So the link I sent you, the link to the workshops, so it is, I sent it to the live chat, and also here, if you're watching this in recording, it is here under the video. So this is the link to the workshops. You can find the other workshops that I talked about that are specifically for ML Zoomcamp here in ML Zoomcamp FastAPI. So this is the updated module number 5. And also ML Zoomcamp serverless, this is the updated module number 9. So in this workshop today, this is the Kubernetes workshop, we actually will build on top of the content we discussed here and here. So if you haven't watched these workshops, you can do that. So you just click on that and you will find videos here. All the materials are here. Yeah, don't worry. So you can just come back later, like walk through these workshops and then come back later to this workshop. And then things may make more sense. Because for some things, I will not go into a lot of details for these things. I will just say, okay, we covered that in the previous workshop. So for you, you can just know, okay, I need to check that workshop first. If you are watching the course, so this will be the recording, you have already saw this and this by now. Okay. Let us start. So for that, I'm going to use, for the environment, I'm going to use Codespaces. So I have Codespaces. So this is an empty repo that I use when I just need to quickly create a Codespace that I'm going to throw away. Just one of GitHub Codespaces. So that's why I have this empty repo that is named Codespaces. So I create a Codespace here, I do a workshop here, and then I delete it and I forget about it. So I don't need to commit any code. If you are following the course, you probably also use Codespaces, or maybe you do not, but this is one of the possible environments. What do you need for this workshop if you're not using Codespaces? Here I will show how to install everything. In the instructions we have, where is it? In the instructions we have, I tell how you can install things on Windows, macOS, and Linux. So here we are going to follow the instructions for Linux. Here, right? So if you have a Linux machine and if you don't use Codespaces, you can just follow along and do what I do. So then it should just work. If you have a Windows machine or a macOS, then you need to have Docker, and then you need to install this. So for Windows, I also recommend installing this package manager, Chocolate, I don't know how I pronounce it, Choco. So you install this, and with Choco you can install many useful things like Kubernetes and well, to be frank, I did not test it for Windows and macOS. I tested only for Linux. So if you're going through this content and you're on Windows and you say, yeah, it doesn't work, please you can create a pull request to this, so then others will not have this problem. Okay, so the plan is that we will set up a local Kubernetes cluster. We will use Kint, which is short for Kubernetes in Docker. That's why we need Docker. So then we will build a simple service using FastAPI, and this will include a model that we created previously. So the model we created previously is the model from the deep learning module. In the deep learning module, we created a model that can classify different types of clothing into categories. So let's say I have a picture of pants, and then it can say, okay, you have a picture of pants. Or I have a t-shirt, and then it can say, you have a t-shirt, a picture of a t-shirt, right? So it's a clothing classification model. Then also in the deployment module, we learned, or at least in the workshop about the deployment, we learned about FastAPI. So we will use FastAPI, and we will use this FastAPI app. We will write it now in order to serve the model we created in the deep learning module, right? I'm going to update the deep learning module. Right now, we are still using TensorFlow. By the time you watch, if you're watching this as a part of the course, it will already be updated. I think it's the stream will be like in 2 weeks or 3, I don't remember. Yeah, so what we're going to do is we are going to take the model from this deep learning model from the module. And we are going to repeat what we did here with serverless, except instead of using AWS Lambda, we will put this in a FastAPI application, and then we deploy it to Kubernetes. So why Kubernetes? Kubernetes is a very convenient platform for deploying applications. It's a little bit complicated. Not everyone is a fan of Kubernetes, but it is still, when I was recording the course 4 years ago and today, it's still one of the standards. So many companies, they still use Kubernetes quite often and quite extensively for deploying applications, also including machine learning applications. So if you join a company and they use Kubernetes, probably you also will need to deploy your models that you work on in this Kubernetes cluster. So probably the Kubernetes administrators will create you several separate namespace just for your machine learning stuff, but then you will be able to use that for deploying your models. That's why I think it's an important module. That's why I want to update it. So Kubernetes, as I said, is how do I actually describe it? So maybe I quickly ask ChatGPT to help me. Describe Kubernetes in one sentence. So open source platform that automates deployment, scaling, and management of containerized applications across clusters of machines. Yeah, so basically what it is a container management system. So we have Docker, which is a way of packaging your application and creating a container. And this container is a self-contained thing of your program, of your application, right? So it has everything it needs. So once you have this image that you can run in Docker, right? So once you have this image, what you can do is, yes, you can run it in Docker, but you can also run it in other container management systems. So for example, Kubernetes is one of such things. So if it works locally in your Docker, it will also work on Kubernetes. That's really cool. That's the main idea behind Kubernetes, that you have a containerized application, and then it can work anywhere where you can host these containers, these images. Yeah, that's the idea behind Kubernetes. Kubernetes is not the only platform. So what are the alternatives? So there are, yeah, Docker Swarm. So I was thinking about Amazon Elastic Container Service, ECS. So this is what I personally use for some of the Data Talks Club services. So for example, this thing that you might have seen, it's actually deployed with ECS. Right? So it's a little bit easier for me because I don't have a team of engineers. It's just me alone. So for me, it's easier to use something that is, yeah, doesn't require Kubernetes. Plus, it's cheaper, right? So I only pay for one container instead of paying for entire Kubernetes. But in bigger companies, you will have Kubernetes. So there are many things. It's like Google Cloud Run, yeah, Fargate, whatever. So there are many alternatives. But the idea there is similar. So you have a container that you develop locally, and then you can deploy it to a container management service, and it just runs, right? So that's the cool thing about that. Okay, so do I already have my Visual Studio Code Codespace? So let me open it in Visual Studio Code. That's what I'm going to use for today's workshop. So I think I can close that. Again, you can use your local environment. It's fine as long as you have Docker, as long as you can install kind and Kubernetes CDL. I don't know how to pronounce kubectl. I think the DevOps people from my company where I work, they pronounce it as kubectl. Hey, ChatGPT, how do I pronounce it? How do I pronounce kubectl? What? Kubectl. Okay, whatever. So did it open? Yeah, it's still opening. I don't know if there are probably people who know Kubernetes, right? How do you actually kubectl? Thank you, Jonathan. I don't know how. Sorry if I butcher your name, but thank you for yeah, kubectl. Did it start? Yeah, I think I did. So then here I am going to close GitHub Copilot. We're not going to need it. And here I have a terminal that I can run. Cool. So now I have an environment with, first of all, Python. So Python 3.12. And I also have Docker and working Docker. So now it should pull the image. So if you can do these things, if you have Python and if you can do Docker run hello world, you're all set. Okay. So now I'm going to do is let me open this thing. So now we need to install some things. So first thing we need to install is this kubectl. So this is a special command line tool. CTL command line tool. Yeah, that's what it says. kubectl command line tool. Yeah. So we need to install this command line tool for managing the Kubernetes cluster. So with this tool, we will be able to create different things there, see the status. So this is for us the way to control Kubernetes, right? So we need to install it. So what I'm going to do now for installing it, I'm going to go to my home directory and I'm going to create a directory that I'll call bin. And then I'm going to download this thing, which should be the latest release of kubectl, kubectl. Right, so I have it here. I made it executable. So now I can actually execute it, right? So it works. But then I want to add this directory bin to our path. So then later I can just write kubectl and then it works, right? So I'm going to open bash rc. Then I'm going to go to the end. I'm going to write export path. And then I have home bin. Right. So this is where the folder we just created, where we put kubectl. I will also put other thing for Kubernetes and Docker. So, okay, I save it. I press Ctrl O to save it and Ctrl X to exit it. And now when I create a new terminal, when I write which kubectl, I get it, right? So it works. Okay, we installed that. Now I will also need to, again, go to this bin and install the other thing, which is Kind. Kind is short for Kubernetes in Docker. So it is a kind of toy Kubernetes cluster that you can run locally. So we're going to do all these experiments here locally in Kind. But everything we do will actually work with any other Kubernetes installation. Like for example, in the course, I talk about EKS here. So with I don't know if there are any modifications needed to actually do this. So yeah, maybe some you will need when you create a cluster. You will need to like specify what kind of machines you want to have. But after that, yeah, it should be relatively straightforward. And you use again kubectl to communicate with any cluster. Okay, so let's do this. So I have this command, which is conveniently already put in this kind inside home bin. That's good. So I don't even need to cd to this folder. So now when I do which kind, I can also see this. And then I think the instructions suggest to check if I can actually execute this kubectl version. Okay, and kind version. Yeah, so both work. So now we're good to go. So we just installed kubectl to communicate with our Kubernetes, and we installed kind, the simple Kubernetes cluster that we run locally. Another thing we need to install is UV. You already know UV from module number 5. If you don't, then you can check the workshop. So this is a package manager for Python applications. And now what I do is I do UV init to create a UV project, and then I'm going to remove main because I don't need it. But I'm going to create an application app.py. So this is where we are going to put the code for the model. So this is where the model will live. But now we need to download the model. So we already processed the model. So we created the model in module number 8. And then in module number 9, what we did with this model is we converted it to ONNX. ONNX is a very cool thing that allows, so you can use whatever framework you want. You can use TensorFlow, you can use Keras, you can use PyTorch, you can use whatever, anything else. And you can convert it, you can transform it to ONNX. So this is kind of model agnostic environment for inference. Inference means applying the model, right? And then you can also, in the previous workshop, let me open it. In the previous workshop, in the serverless workshop, we actually took this model. So we took a Keras model and we took a PyTorch model, and we converted them into ONNX. And here, I think there is some code. Yeah, you can just walk through this workshop, but at some point, I think we did ONNX conversion. ONNX. Yeah, so we downloaded the Keras model, and then we converted it to ONNX, and we had this model, right? So we don't need to do this now. So I will just simply take the model we already trained. Although I will not be using this TensorFlow model, I will be using the PyTorch model. So that's another section. Where is this PyTorch model? Yeah. So there is another model. I just exported it as ONNX, and then here it is. So this is the model we are going to use, right? Okay. So let me do that. Yeah, I lost it. So let me close this one. And let me do this. Yeah, actually, I was a bit too fast, so I needed to create a directory. Oh, let me just do everything here in the main here. So here instructions say create a directory called service. I am going to just continue doing everything here in the root repository. And I need to download the model. So this is the model we converted previously. So this is the ONNX model, and we save it here to this ONNX. So what I'm also going to do is add it to git ignore, so I don't accidentally commit it. ONNX. Okay, so now it's gray. It will not be committed to Git. So we don't want that because it's it's not like a super huge model, but it's still 9 megabytes. Yeah, it's big. So we don't want to commit it to Git. Okay, so now what do we do? What do we put here in this file? So first of all, maybe let's install the libraries we need. UV add, was it FastAPI? Well, I will not rely on my memory. I will just take it from here. FastAPI, UVcorn. So these are the things we need for serving FastAPI, right? So ONNX runtime is something we use for running this ONNX model. This is something we used in the serverless module. Right? And then the last thing, this Keras image helper. This is a very helpful utility class that we also used in the serverless model. Even though it says Keras image helper, what is that? Go away. So it's a very convenient helper for downloading images, for processing them. And originally I wrote it for Keras, but it also works with pretty much everything. Okay, so we installed everything. And now we need to write the FastAPI code. So what I'm going to do is I'm going to take the thing we wrote here in the serverless model. So let me go to Lambda ONNX. And here we have this Lambda function. So what this Lambda function is doing, so it is creating this runtime, right? And it is creating this processor from Keras image helper. It's applying some preprocessing. And then at the end, yeah, so these are the classes that we have for the model. And at the end, what we do is we use this Keras image helper preprocessor to get an image and also apply all the preprocessing in it. So we download the image, we turn it into like a NumPy array, then we apply this preprocessing. So then it is ready to be put inside a neural network. So we are doing that. So then we have this X, which is a processed image, and then we put it. This is how we execute ONNX, right? So we say that yeah, it's a bit technical, but we just say okay, like for this, give me the output. So this result contains different scores for each of these classes, and then we just show the classes, right? So what we're going to do is simply take this code and put it inside our application, right? So it doesn't look very nice, but yeah. So this is the code we're going to use. But now we need to turn this into a FastAPI application. Now, we already learned about that in module number 5. So maybe what I'm going to do now is I'm going to just go there and take a look at our predict.py. So this is what we created there, right? So first of all, we need to make these imports. So for this one, clothing, not new. So, okay, this, and then I'm going to create an app that I will call clothing model. And then here we will get a post request. So now we just need to classify. So this will be our request. Class request base model, which is, yeah, actually, I like the suggestion from Copilot. So I can, like, what I would do is I just leave it at this, right? So it's just request with URL. That's all we want to send, right? But this one is helpful because later you maybe remember if you attended the previous workshop. In case of FastAPI, you can see documentation when you go to /docs. We will see it later. And here, the fact that I include the example will help us to, yeah, it will just show that this is what you can do when executing. You'll see. So now let me just, I'll use this URL, bit.ly/ML bootcamp pants. It doesn't work. Why? Okay, oh, that's strange. Maybe I should use HTTP. Okay. HTTP works. Okay, so then, yeah, let's actually do that. So for now, we'll just do a request and return a dictionary. Yeah, thank you. Thank you, Copilot. We will later, maybe we should actually create its dictionary string float like that. Yeah, maybe we should actually create a proper class, but yeah. In the workshop that I have, in this example, there is, somehow slow. Yeah, we have this code. So this is what we do here. So predict. Yeah, I mean, prediction is dictionary string and float. So we can just leave it at that. Okay. And another thing that we should include is this health. So this is like just ping that you can use. So this is something important for Kubernetes applications, something we didn't do. So Kubernetes constantly sends requests to a certain endpoint to make sure that the endpoint is still healthy, right? So it's very important for us when we want to deploy to Kubernetes to provide this endpoint for the health check. So if Kubernetes sends a health check ping and doesn't hear back from the service, it assumes it's dead, and then it tries to kill it and restart, right? Is the whole process of creating a custom-based model that only includes a primitive type like string considered good? Yeah, I don't know. Like, to be honest, like usually the requests I have, they are bigger, not just one URL. But I don't think it really hurts, right? Then we will have here actually an issue. So we have predict and predict, right? So predict single. So let's call it like that. Okay. And now the last thing we need to add is this thing, right? Why doesn't paste? So I think I think my Copilot is trying to take over. Okay, so let's run it. If it doesn't work, then I'll just copy whatever code I prepared. But I think it should be working. Okay, load model from clothing on NX failed. And that I didn't expect that. Did I? Model name, let me check that it actually, yeah, should be fine. So you know what, what I can do is I can just read and load it. RM clothing model and download it one more time. Okay, so I hope that solves the problem. Does it? Okay. I don't know what happened, so probably the file was corrupted. Then let me create a new terminal. And here I'm going to send first a health request, just a get request to this slash health. Localhost, what's the port? 8080. 8080 health. Okay, status healthy. What Visual Studio Code already did is forwarded this URL. So now I can go and open it on my localhost, port 8080. And then what I want to open is docs. So because we used an example here, so remember I was talking about this thing, right? So because we provided an example, now we can see this example value. So now when I click, yeah, well, we don't have an example value for the output, but we have example value for input. So we can actually test it. And the output is this. Yeah, cool. And we see that the score for pens is the highest. So actually the code I have here is a little bit more complicated. So maybe we can do that. Complicated in the sense that, yeah, it's doing more things. So here, just for the sake of doing this, So we have this predict response that also contains top class and top probability. So then we can immediately see what is the like what actually is this that we have on this picture, instead of going through like this list and understanding, okay, is it pants or something else has higher score. So we have this predict response. So now let me, first I want to close it, and I want to close this thing. So now I have a little bit more space. Okay. And then I will return predict response. Now, okay, yeah, that's what Copilot did right now. So what happened, I fully agree with this. So what it did is selected top class from the predictions, right? And then probability for this class, and then returned it as top class and top probability. I think it automatically reloaded the code, right? Did it? Yeah, it did. So what we can do now is we can try to execute it one more time. Yeah, so now we have a new response. Top class is pants, and this is the top probability. Okay. Question: what happens in case of dynamic model loading? How we can achieve dynamic loading? So one of the possible things, yes. So here we have the model. I maybe shouldn't open it. That's why I hope it will not mess. So here we have the model, right? We put the model near the file. So then we just load it here, right? So we just say, here is the file, load it, right? Alternatively, what we can do is we can put this file somewhere on S3. And then when our model, when our service starts, we then first download the model and then start serving it. So this is like two different approaches. I personally prefer downloading the model at the beginning, putting this inside Docker file, and then serving this Docker file. And then internally, inside the Docker file, you just download. This is what we are going to do now when we package everything in Docker. So what happens inside is, yeah, you just have the model inside the Docker, and it just reads locally. Why I like this approach? If something happens with the model, it's very easy to roll back. So especially with Kubernetes. With Kubernetes, when you deploy something, you provide a tag. So let's say you deploy a new version of the model. You package this in Docker, you publish it to your whatever registry, this data, and you update the tag, right? And if something happens, you just roll back to the previous tag, and then it works. Yeah, so it's easier. It's way easier. Model management is easier. Then scaling up is also easier. So we will talk about scaling up. We will talk about horizontal autoscaling. When they start scaling, the Kubernetes cluster already has the image, right? So then it's easier for it to scale up. Otherwise, each of the separate pods, so pod is like this mini container, will have to individually download the models, right? And then startup time will be slower. So this is from my personal experience. Sometimes, in some cases, when your model is large, it's not advisable to put it inside Docker container. It's better to load it from S3. But yeah, so far my experience was that when it comes to ops, the ops part, managing models when they are inside Docker image is way easier, because if something happens, you just roll back, right? So it's easy. So the image is self-contained. It doesn't have any external dependencies. And not always possible, but if possible, I would stick to this approach. Okay, so it's working. And now the next step is create a Docker container, right? Docker file. Again, I am going to borrow the code we previously wrote. We wrote this for our, so I have so many things open. So we wrote it here, right? So I'm going to just borrow this code. Yeah. Or maybe instead of doing this, so the idea is similar. So we want to install ONNX or ONNX runtime, Keras image helper. Also, we want to install FastAPI, and we want to install UVcorn. But we also use UV, right? So for us, it's better not to use this code or combine this code and the code we have here. This is something we wrote when we were creating our first FastAPI application. So this is the code we had. And I think I'm just going to copy this and use it here. I don't think I need to change much. So maybe what I need to change is this part. So here we have app, and here, yeah, app. And here we have clothing model. ONNX. Do I need to change anything else? I don't think so. I think it should be good too. Although I would check first Python version. I think I have a different version of Python. So yeah, just to be on the safe side, I'm going to use this version of Python that I have here. Okay, so yeah, let's check it. So I will close this, and this. So we already run it locally. We tested it. I am just going to go to this Docker part. Where is, yeah. So let's do Docker build. So what we are doing here is we're building whatever is in Docker file, and we're tagging it with clothing classifier. And I need to stop this one. And because right now I want to start whatever we just built. So, oops. Why is it trying to open it? Okay. Docker run it minus it minus rm port 8080 clothing classifier. Okay, it seems to work. We see that the port was forwarded. I think actually it should be this port, right? So let me stop it. So 9696 is something I used in the previous workshop. Here, for some reasons, I am using the default one from Flask. But yeah, I think it's still 90. What? Oh, right, because I need to rebuild it. Cool. And now I just do a quick health check test. Curl localhost 8080 health. Okay, so it works. Now I can go again here and execute it one more time, and then I see the response. Cool. So we deployed it to Docker and it still works. And the reason I didn't even refresh it, because like it sends, so this is already in the browser, and it would send a new request. But yeah, let me convince you that this is correct. Okay. Well, we deployed it. It was very simple. So I just copied the code that we already had and replaced a few things. And thanks to UV, we didn't need to worry about dependencies. Like in this case, dependencies are different, but because all our dependencies are specified here, we just copy this by project YAML, and we just do UV sync locked, and we don't need to worry about dependencies at all. Okay, that was fairly easy. So now we have the Docker container, we have the app, we have the Docker container. Now let us deploy it with Kubernetes. So I'll create a folder. I'll call it K86. I was always wondering, like, why people abbreviate Kubernetes as K86. So yeah, I wonder if ChatGPT knows. Well, actually no, because there are 8 letters between why Kubernetes is abbreviated as, so because there are 8 letters here, right? But to me, this is a very weird abbreviation. Hey, come on. Okay, I'll take a sip of water in time. Yeah, I heard ChatGPT is not good at counting, right? Yeah, it's very slow. Yeah, 8 letters a minute. Anyways, so this is what we're going to do now. By the way, another thing that I want to add to my git ignore is venv. Right, so this, so we don't want to accidentally commit it to Git. Okay, so now we need to create our first, we need to deploy it with Kubernetes. So in Kubernetes, we have, so I said I will not cover theory, but maybe I'll do this quickly. So in Kubernetes, we have multiple things. So there is a few definitions. So nodes, we have pods, we have deployments, and we have services. So when you watch the lectures, I go into details what is what. So nodes are physical, oh, not physical machines, but the machines. So let's say if you run this in AKS, so one node would be one EC2 instance, right? If you are running Kubernetes on-prem, some people do this, you have some physical hardware in your I don't know, server room. So then you install Kubernetes, and the nodes would be the machines. I don't know. I heard some people install Kubernetes on Raspberry Pi, right? So each Raspberry Pi would be a node. Then pod is one single instance of an application. So when I do this, when I do Docker run, so this thing, it would be running on one pod, but we can run the same thing on multiple pods. So this is how the deployment is a group of pods that serve the same purpose. So let's say we want to deploy our application and we want to make sure that when there is a lot of traffic, so let's say, I don't know, 100 clients send requests, right? So they send requests to one pod, to one application. And at some point, this, well, 100 is a lot, like let's say even 10 would be, because it's a deep learning model. But let's say 100, just for simplicity, right? So at some point, this thing will be just too busy. It will not be able to respond to all the requests, right? So then what we can do, instead of having one, we can scale it to 2 pods. So it will be exactly same instances. So it will be exact replicas. It will be the same image, the same tag, just deploy it multiple times. And in front of that, so this is called deployment. And in front of that, we have some sort of load balancer, LB, right? So I think that decides to which pod to send the request, right? Okay, trying to. Okay, so it's centered, right? So there, in front of this, there will be a load balancer that decides to which pod to send. Like at some point, let's say we have 9 pods. If I do 10, then it's not centrally aligned anymore. So let's say at some point we grow to 9 pods, right? So then the load balancer would decide to which pod to send. And this is what a service is doing. So a service would be load balancer, and then the pods would be a deployment. Right? And then we have also another abbreviation, HPA. Is it HPA? Horizontal Autoscaling. Yeah, Horizontal Pod Autoscaler, HPA. So I was right. Yeah, ingress. That's another thing. So let's not. So in the videos, in the lectures, we talk about ingress too, but like it's getting complicated. So HPA is the thing that decides, okay, how many pods do I need? Like, is it one or two enough, or I actually need 9 pods, right? So this is what HPA is deciding. Okay, so this is the main concepts that you need to know. More you'll see in the lectures. And so what we need to do is we need to define a deployment. So it's going to be a lot of YAML. I will not be able to type this from memory. So what I'm going to do is I am just going to copy the thing I already did, which is, I think I skipped one step, but I'll come back to it. Okay, so let me copy this, and I'm going to explain what's going on here. So here we have a deployment, and this deployment is called clothing classifier. So this is the name of the deployment. In this deployment, we have 2 replicas. It means that at the beginning, we are creating a deployment with 2 pods, right? So it will be the same model running 2 times. So there will be 2, not machines, but like 2 mini containers, right? So we can, right now, if I do this Docker run, I can do it twice, right? So once on one port and second time on some other ports. Then I will have 2 replicas of the same thing. So this is what actually Kubernetes and Docker is doing. So it's just running multiple Docker containers. Maybe I'll do Docker PS and we'll see that. So we'll have 2 replicas. So this selector is to just match between. So here you see this spec. So this is template is how we define the pod. So we define the pod here, and we give it some label. And here we need to define this. So anyways, this is just boilerplate. Let's not worry about that. Basically, what we need to worry about is that thing is always the same. So there are probably reasons why it was done the way it was done. But for me, I just make sure that they are always the same. Right. Then here we have the specification for the pod. Right. So here we have the image. So this is the image we built here. Where it is? Yeah, Docker run. So this is the image that we built here, and this is the step I missed because we will need to make it available for kind. Right. So this is the important thing. So we say, okay, this pod uses this image, and let's say if we update something, we create a new version of our application, then we just simply replace the tag here. Then we say, so this is the mapping thing that we have here in Docker, right? So we say, okay, there is actually a port that is exposed on this container, and this is then a port. And then we also say how much resources we give. So we, at the beginning, give, I don't remember this this notation. So let me check. I think it's like a quarter of CPU. Like, let's see, there's ChatGPT. Did I copy it? What does this notation for CPU mean? So I think it's this is a quarter, and this is a half of CPU. So millicores, okay, which is a quarter of CPU, right? Millicores. I didn't even know that such thing that it's a thing, millicore. Okay, so yeah, with memory it's clear, right? So here there is a request. So when we initialize a pod, this is how much resources we allocate for this pod. And remember, we have nodes, right? So a node can have like 8 cores and 16 gigs of RAM. So it means that on this node, on one of this node, we can have I don't know, 4 times 8, right? At most. So this is how many pods can fit on one node. Right now, I'm running this on Codespaces. I have only two. Wait, I have only two cores, right? So 1 and 2, and I have 8 gigs of RAM. Okay, so then, and at most it uses only a half of CPU. Then this liveness probe, we talked about this. This is the health endpoint. So it will periodically send a GET request to this endpoint. And if the pod doesn't respond, then it assumes that the pod is dead and it restarts it automatically. And then the same with readiness. Readiness means that it gives 10 seconds to readiness. So it gives 5 seconds for this to initialize. And if in 5 seconds it does not respond to this health request, then it tries to restart it. And it starts sending health requests only in 10 seconds, I guess. So this is how you read it. Okay, so that's our deployment. And what we do is I'm going to cd to this Kubernetes folder. We will finally use this kubectl and kubectl apply -f deployment. Right, so this is how we are validating. Did I copy it incorrectly? Right, this is the command I forgot to execute. So we needed to execute, where is it? Docker containerization. Yeah, so we need to make this image clothing classifier available for Kubernetes. And probably I missed another step. So let me see. And because there is probably initialization step that I skipped. Kind create cluster. So we will create a cluster. Okay. So while it's creating cluster, let me take a look at the questions. So if we put a service to a load balancer and it has multiple pods, we should avoid using local disk storage. Should we use cloud blob storage then? So it's not a problem if you use local storage. It's okay. Just keep in mind that when the pod is killed, the local storage is gone too, right? So this is the same when we do this minus rm, when we run Docker containers. It may write some things to local disk, to the disk, but then it's gone once you stop the application, right? So it's not a problem if you need to do some caching. But yeah, let's say if it's a database, then you need persistent volume mapping, I think. So persistent volumes, you need persistent volumes. This is not what we are going to talk about. It's a little bit more advanced, but then ChatGPT will help. But for us, our applications are stateless, so they don't really have any state, right? So the only thing they need is this model, and the model is already baked in the image. So they don't need to save anything. They don't need to read any extra data. So for us, it's good. We don't need. It's actually good for our applications to be stateless. And when we talk about databases, like let's say if we need to have, I don't know, some sort of cache, we would use, I don't know, maybe Redis. And in case of Redis, perhaps we want to have some persistent storage. But then as a machine learning engineer, you probably will work with DevOps and SREs to actually do this. Yeah, persistent volume claim. Yeah, thank you, Lukasz. Okay, I think it's done. Then the next step is here, load Docker image. So now we make this image available in that Kubernetes cluster. Okay. Takes a bit of time, although it shouldn't, because our image is fairly small. Okay, now we can do kubectl apply. And now we can do again kubectl get pod or pods. Or just get p. No, doesn't work. Okay, get pods. We see that we already have 2 pods because we have 2 replicas, right? And then we can actually see what is inside these pods. kubectl, describe this. And if we want, we can even, I don't know, start a bash session. Describe pod. Then we can see what exactly is happening in this pod. And we see name of the pod, like all this stuff, IP. Well, yeah, that's not really interesting. Let's also take a look at deployments. So this is the deployment that we created that has 2 pods. So we can see that there are 2 already, 2 are available. Up to date means that if we want to roll out an update, so let's say we want to change this thing to v2, then not everyone will be up to date immediately, right? And then we can also describe deployment this. Yeah, so we can get some information about it. Anyways, so we have the deployment, but as I told you here, the deployment is not enough. So when we send the request, of course I can send the request to individual pod, but it would not be convenient, right? So you never know to which pod to send, which pods are available. So you need something that knows which pods are out there. So then it can get the request and it can forward to any of the pods, right? And usually it's doing it randomly or some sort of round robin fashion. Usually it's randomly. Maybe it's configurable, but anyways. So yeah, we need to create this service now. So what I'm going to do now is create service YAML. And then that's another big YAML file that I am not going to try to type from memory. Okay, this I don't need. My VS Code froze. Maybe it's again Copilot is trying to take over. Oh, yeah, it was actually trying to take over. Okay, so what do we have here? So here we have the name of the service, and we have the app selector, right? So this is how it knows which pods to look for, right? Because we have clothing classifier here, so then this is what it will be looking for. And then we have port 8080. So this is our target port on the pods. Wait, I think this is the port we have on the pods, and this is the port we have on the server. Well, actually, I don't know about that. I forgot. But the important thing here is this port, right? So this is what is going to be exposed. This is what we are going to send requests to. Right? Okay, let's apply it. kubectl apply -f service. So service is created. kubectl describe services. Now, why it takes so much space? Yeah, maybe just because it's one. Yeah, I want get, right? Not describe. So we have this clothing classifier, type node port, cluster IP. So actually, like it creates a simple, very simple, like kind of computer that is only doing load balancing, right? So then it has its own IP and yeah, some port. So this is the port that it exposes outside. Right now, it should be running, I think. Well, because all the pods are running, the deployment is up and running. We technically should be able to already send a request. So what I'll do now is curl localhost. This is the port, right? 38, yeah. Health. But it won't work. The reason it won't work, we need to make extra configuration to actually, so when we deploy it as not port, we need to install extra things, and I don't want to spend time on that. So what is easier to do is we just forward one of the ports, this 8080 port, from the service instance, whatever, and we forward it to our local, to our host machine, right? And then we can send requests there. So this is easier to implement locally. When you do this on AWS, for example, so then this service is actually you can configure it to be a load balancer, like elastic load balancer from AWS. So then it will have its own URL, and then you will not need to worry about that. So then once you deploy, you will have the URL, you will have the IP, and the port will be open there, right? So I show it in the other video that we have. But here we will need to do this little hack. So let me just do that. You see, this is what we do, port forward. And this port forward thing, you can actually port forward not only from service, you can also do it from a pod. So let's say you deployed something and something is not right. So you want to debug it. What you can do is you can forward a port from the pod, forward a port from a pod to your host machine, and then you can send the request there to see how this pod responds. Okay, so let's do that. So now we have port forwarding. I think I need to stop this, right? So now, actually, it would be interesting. I think this is something I promised you to do. Docker PS. Yeah, I don't see many things. I see this kindest note only. Okay. Anyways, so we have a port now, and now, like this service, the port from this one, we map to this one. So what we can do is I can send a request, local host. What is the port? Oh, okay. So we now can reach the service, and yeah, we can also send the request. So let's actually do that. But I need to use this port. I don't know why actually I decided to map to this port instead of. Try it out. Execute. And we get it. So now actually this request is following this path. So there's only one client, but then it hits the service decides to which pod to send the request to, and then one of the pod responds with this. So we almost covered everything. One last thing I wanted to talk about is this HPA, Horizontal Pod Autoscaler, HPA. So when we have a lot of clients, right, and all these clients send requests, we want to scale from 2 pods to 3 pods, from 3 pods to 4 pods, and so on, right? So let's do that. So yeah, to-dos for me. I will do this, but now, yeah. So we need metric server for that, metric server. So metric server exposes some metrics, like how much CPU is being used. Well, yeah, I will keep this running. So how much CPU are being used, how much CPU is being used on each of the pods, right? So this is what we need to install. And then once we have that, our horizontal pod autoscaler should work. Yeah, another thing we need to do is to patch this metrics server to work without TLS. So basically, we don't use any HTTPS. So we run things locally with just HTTP. That's why we need that. So yeah, we are running things insecurely. Okay, and now, yeah, while we're waiting, so we can wait. So it takes some time. While we're doing this, let me actually put the code. So what do we have here in this code? So this is HPA for this deployment, and it controls how many replicas are there. So we can say the minimal amount of replicas is 2. So when we don't have a lot of requests, let's say when there are 0 clients, when there are 0 clients, it scales to 2. But when there are, I don't know, 100 clients, it scales to 5, right? So using some logic, in this case, we rely on CPU utilization. We can also look at the number of requests it's getting. Sometimes for machine learning applications, actually a more reliable metric, like how many requests we're getting. And this is something that is more like art than science, like knowing these things, like how to properly configure your autoscaler. I was always working with DevOps engineers with SREs to configure this properly. So it requires some tuning. But yeah, let's actually do this. So here we have a minimal amount of replicas and maximum amount of replicas. And we scale when the CPU utilization is more than 50%. Right? So this is our HPA config. Our metric server is ready. So now I do kubectl apply -f HPA. Okay, I need to go to this Kubernetes folder. kubectl apply -f HPA. Okay, it's created. And now we can stress test it, or not stress test it, but like we'll just send a lot of requests. Test, how do I call this? So we'll just send a lot of requests here and see how it actually scales. So how it load test. Okay. Load test. So this code I asked the AI to write. So this is not something I wrote. I edited later, but AI wrote this code. So here we configure how many requests we want to send and how many concurrent workers. So how many clients? So let's say we have 50 users and they are sending requests nonstop, right? So this is the configuration we have. And this is we're creating a thread pool executor to do this. So we can do this in parallel. And then at the end, we see how many requests we were able to send, how many of them are successful, and how many of them failed, right? And they fail when our autoscaling cannot work, right? When it didn't react in time. So, okay. Now I use UV run Python load test. We're starting the test. Did I not have it? Okay, so now it's sending requests. Maybe it would be nice if we saw some things, but okay. What I can do in parallel is we can see how many deployments we have. So kubectl get deployments. I think we should be watching HPA, right? Get HPA. Yeah. So let me see. Yeah. So what we have is we have targets, we have number of pods, maximum number of pods, min, max, and how many replicas are right now. So we see that actually like it's increasing the targets are like it's almost 100% utilization. So now you see it increased it to 4 replicas. So now it's like below target. So it's not increasing it. So now for replicas are actually able to handle the load, it seems. And what we can do also is watching it. So add this -v. So I don't need to, and I think it's done, right? So because it's 0%. Let's see. So this is our load test. We were able to send 20 requests per second. It took 1 minute, and all of the requests were successful. So in my experiments, when I was running it, actually 2 requests were not successful, 2 failed. So now it worked even better. Okay, that's how you autoscale with Kubernetes, and that's why people actually like using Kubernetes, because these mechanisms for scaling are clear. They're battle tested. All the DevOps engineers, all the SREs, they know how to deal with this. That's why it makes Kubernetes such a popular platform for deploying everything. And when you join a company as a machine learning engineer, they probably already have a Kubernetes cluster. So you will probably need to deploy things to this Kubernetes cluster. And now you know how. So yeah, I think that's it for this lesson, for this workshop. If you have any questions, you can ask them. I see that you can install K9s and see everything happening in your kind cluster instead of writing commands in your terminal every time. Yeah, that's a very good suggestion. I have not personally used this tool, K8s, but I remember seeing my colleagues like with this. So it looks something like this, HTOP, but it's for Kubernetes cluster, right? I remember like it looked super fancy. It's like, I felt like they're hackers. They're like the cool guys. Yeah, I guess let me check what else I have here. So I guess the rest is just some information for you that you can check later, like how you update classifier, how you update things. Yeah, so for example, instead of applying using YAML, you can use kubectl to say, okay, like I now want to update it to version number 2. But yeah, I would just update YAML. I think it's easier, it's better. And then it's also in version control in Git, so it's version control. So every time you want to change something, it's better to make a change in Git, in YAML, commit this change. So then if somebody needs to change something, the state you have in Git and the state you have in Kubernetes cluster should always match. Okay. Yeah, you can just go through the rest. I don't think it's super interesting. Okay, that's basically it. Question from Alan. Could you talk a bit more when you decide between stopping at just Docker deployment or moving to Kubernetes? Well, the thing is, with just Docker deployment, how can you do just Docker deployment, right? So you have just Docker deployment is something you do locally. But with just Docker deployment, how do you restart if things break? Like, how do you monitor? How do you check for health? Like, how do you check that your containers are actually running? How do you collect logs from all these things? So this is all important for production. So I don't think you ever just run Docker container. You always need to run it in some sort of container management system, and Kubernetes is one of them. The question is when you need Kubernetes, that's a different question. So for example, I told you at the beginning that so for our courses, we use this platform, right? So this platform is deployed to, I think it's getting pretty dark. So this platform is deployed with ECS, which is not a Kubernetes installation, not managed Kubernetes. So this is an alternative to Kubernetes, which is more lightweight. But then at the end, it's still a machine that is running on AWS, and then there is a Docker image. And every time I make an update, this is, it's actually automatically goes here to dev courses. So every time I make a commit to Git, it goes here, deploys automatically here. But then when I choose, I want to roll out this update to the production version. So this is how you typically do it also with models. So you typically have a development environment where you can go crazy and test all the things you want. Yeah. So in my case, when I was working as a data scientist, I would experiment a lot with the dev Kubernetes cluster. But then deploying things to production is something I wouldn't personally do. There would be somebody who actually can do that, or somebody like SRE or somebody would be present when I do this, or sometimes they would do this. Okay. In real production, do we use kind also? No, you don't use kind. Kind is just for local testing. So when I was learning Kubernetes, I used Minikube, but later I found out that kind is way more convenient. Yeah, so this is for me, maybe people who know this thing better can correct me, but for me, kind is something you use for learning Kubernetes, for testing things locally, but you don't really do production with this. What is the best way for an experienced DevOps engineer to transition into MLOps and AI engineering role? How deep should they dive into machine learning? When it comes to ML engineering and MLOps, so what we cover in the ML course should be enough. Like you don't need to go super deep into that. That's my opinion, right? Especially if you're talking about MLOps, which is more like operational part, like maintaining the Kubernetes cluster for the ML team and things like that, right? So for that, you don't really need to know a lot of machine learning, but maybe some basics. So if you're on call and something happens, you want to understand what to like do a rollback. Is the reason something is breaking because a new model is deployed? Like, what is this model? So this is helpful if we talk about strictly ops roles, right? If we talk about ML engineering, of course, it's helpful to know more ML engineering, at least at the level of what is presented in the course. Like, can I find it here? Like, you know what regression, linear regression is, you know what is logistic regression, you know how to evaluate models, you know what XGBoost is, you maybe know what like simple deep learning models. You probably will not need to go deeper than that. At least when I was a data scientist, I didn't need to go way deeper than that. Yeah. When it comes to AI engineering, maybe it's a little bit different. But AI engineering these days, it depends on the company, of course. But for many companies, it's just making calls to OpenAI. So at the end, it's just more like data engineering skills, putting things together and making sure they don't break. So making sure the data flows. Yeah, so it's like data / usual backend engineering, I would say. Do we only use GKA in production? GKA is GKA is Google Kubernetes engine, I guess. Yeah, Danke AI. So yeah, it's decided that it should be in German. So Google Kubernetes engine. Yeah, well, you use something like Google Kubernetes engine or uh, engine from Azure or Kubernetes from AWS. So typically this is easier. Yeah, or some companies actually like, especially in Germany. So here, since we have a German thing, especially in Germany, some companies they still prefer to have their own on-prem Kubernetes cluster, or they prefer to have on-prem servers. So because they don't want Americans to be able to access the data, of course, very important, or anyone outside of Germany. Maybe Swiss only can do this. So yeah, in this case, some companies have servers on-prem and they run Kubernetes on top of that. Yeah. Yeah, I don't see any questions, and it's actually time to wrap it up. So thanks a lot for attending this. It's so bright. So it was very dark. So when I turn this on, it's kind of very dark. Anyways, I'm going blind because of these lamps. Thanks a lot for attending this workshop. So this workshop will be a part of the course now. And the only thing I need to update is this deep learning model, where I will show you how to train models with PyTorch instead of TensorFlow. So that's it for today. Thanks a lot for coming. Thanks a lot for asking questions. Thanks a lot for helping me with these tricky parts like why Kubernetes is K8s and things like that. So I hope you enjoyed it, and see you soon.